So yeah, I want to say thanks to everybody who's here for the ZK Study Club, where we're going to be actually looking at privacy post-quarantine in a way. I want to use this time to explore opportunities and challenges that are going to be facing privacy tech as we move into a post-quarantine state. I just said this before we started recording, but I'll repeat it. Sort of the goals of this session are to identify what are the projects actually emerging in different countries and potentially states around this. It's not purely ZK that we're looking at. It could be other privacy systems that are related, or maybe there's systems that are emerging that could use it and aren't yet. I think the goal of this is to have a little bit of feedback. I think Daniel made a good point here where we can also cover, or we can also have as a goal, what are the most difficult barriers to have adoption of these systems? And yeah, and then the other purpose of this is to highlight a little bit who here in the group is working on what, so that we can get a bit of a sense of what we could do after this in terms of more study clubs, maybe a podcast, stuff like that. So I know that Henry, I was going to kind of ask if you could share a little bit about what you're working on, because everyone, we're sort of aware that you have a project, and then we can sort of open the floor to other projects that people have seen.
Sure. So, maybe the best way to sort of lead into this is by giving a little bit of history. So a few weeks ago, I put a blog post on the Zcash Foundation blog, basically saying that contact tracing is sort of one niche sub area of coronavirus response where cryptography is actually potentially useful. And as a result of that post, we got in contact with Scott Liebrand and Dana Lewis, who have a project called COEPI, which is community epidemiology. And that's trying to do like decentralized self-reporting of symptoms. And they had already made contact with another group called COVID Watch, that is in some way affiliated with Stanford, or some people are there, okay, who are trying to do a coronavirus alerting app, and they had already agreed that it made sense to try to have a common protocol. So they were working on that, and at that point, I started helping with that, and the result of that was a protocol for doing contact tracing called CEN, and then turned out that there were all these other applications that were also trying to do this, and so the kind of common protocol level was, or the common protocol level work was spun out into a new org called the Temporary Contact Number Coalition, TCN. And so we have a protocol. There's like a 0.4 version on it, so it's still unstable, but it does work, and it lets you do basically decentralized contact notifications, and it's designed to be extensible so that it's compatible with a bunch of different use cases. For instance, you could use it to do only authenticated test results that are, signed by some health authority, or you could use it to do self-reported symptoms, but still be interoperable.
So this is coming out of these, from what I understand, it's kind of like somewhat independent organizations, but is there like an adoption path? Is there a way for this to actually be used? Is it going to result in an app, or will it be integrated into something?
Yeah, so there's a number of different application developers, and the effort for doing a common protocol is basically has come out of the desire of those app developers to collaborate. So the path to adoption of the protocol is just the path to adoption for all of the constituent applications.
Okay.
Um,
Are they already, are these, oh, go ahead.
Sorry, Henry, out of curiosity. So are we really doing self-reporting and doing some machine learning on top, or is it just, I have a cough, I have a fever, I'm just going to report this, and when you have the result, have the curated data set to actually do something with it, or is it just contract tracing per se? The security requirements of both are very different. That's why I'm asking.
So I think that it's better to, so traditionally, right, contact tracing normally refers to like an activity that can be done with various tools, right?
Yeah, I'm a medical doctor, among other things, so I understand fully epidemiology of the whole thing.
So I'm just not for you, but just to kind of like
sure.
lay out all that, right? So I think that for this system, it's really better to think of it as like contact notification rather than contact tracing. I think that there are different possible use cases that are each valid, but that require setting different user expectations. So for instance, the CoEpi project is explicitly just to do self-reporting of symptoms, not just for coronavirus, but also for like flu-like illness.
Okay.
And COVID Watch is focused on doing authenticated test results. And so the protocol is aiming to be compatible with both of these use cases, even though they have different security requirements, as you know.
Yeah. So question for you. So essentially, there are existing, so I know of somebody who went to Stanford who actually runs influencer, what do you call that, watch thing. There are like a bunch of people who are doing that. Are we thinking of actually offering them this possibility of reusing whatever we end up building, what you end up building, so we could continually do that? Because it's an ongoing process. This is
I think that
we are hoping
yes.
Okay.
I'm not as plugged. I have a kind of a peripheral understanding of everything that's going on there.
Yeah.
Because even just trying to stay on top of the developments for the protocols is challenging. But my understanding is that the goal is that it would be nice to be able to reuse some of this work. And I know that for the CoEpi team specifically, one of the side goals is to have the to be able to build anonymized volunteer data sets about symptoms that could later be used by people to do
machine learning in that sense,
studies. Yeah.
Are there some other kind of systems that maybe other members of the group here are working on or are aware of in their particular regions? I sort of want to open the floor, and you're probably muted, so you have to unmute yourself.
I know that the European Union or European Commission had an actual fund that the application was over like maybe a few weeks ago to explicitly have like funding of projects that are going to do like things related to coronavirus, right? It not necessarily privacy related, but I think there were probably several submissions around that.
There was, I'm going to say one of them, there was this PEP-PT, Pan-European Privacy Preserving Proximity Tracing. They really like the P's in this one. I'll stick the link. It's got a website. I've started to explore it. It was kind of brought up actually in the podcast that went live today. We did the interview last week and this was sort of mentioned in it. Does anyone know anyone working on that, or is anyone familiar with this project? Oh yeah, just unmute yourself if you want to. There you go.
So, I mean, I'm not working on that, but I have, I mean, I have been following this a little bit. So, as I understand, I mean, it was some kind of, there were some kind of, a group of universities working on this. And there is this protocol called DP3T.
Yeah, DB3T. Yeah.
That somehow resulted out of that, but it's not exactly the same as as this project, but somehow like a decentralized version of what they wanted to do. Yeah, apparently there must have been some kind of disagreement, internal disagreement, or some kind of different focuses of the people working on this project. And so this EPPPT is like described as some kind of umbrella for different projects. But the only project that I actually know is this DP3T. I think maybe there is some kind of other centralized version of that, but I haven't seen anything.
Yeah, I can find the link on that if you want. I just posted.
I saw a paper recently that actually ripped the guy from EPL didn't take too kindly with the DP3T technique, because it's privacy preserving, but the servers can the way it's set up, the servers can collude, so it was seen as not having the strongest privacy guarantees, or not being as good as it claims to be.
I think that might be, is this what I just shared, this analysis of DP3T? It just came out on April
2020-399.
Yes, that's it.
Yeah, I think that was actually shared in the group too. So that's interesting.
Oh yeah, we actually had a few talks with those professors. We had a thread of discussion, and yeah, it was kind of hard to, highlight the issues with that protocol. We even suggested like a different one, but it seemed to be not leading anywhere, basically.
Was this like you were meeting with them because you had seen it and you reached out to them, or were you in this, or were you in the working group?
We saw it and we wanted to contribute, and we wanted to present like an alternative one, but we didn't manage to make it go through. So what happened in the end, we found another professors from ETH, and that now we're writing a paper, they're writing a paper, and release it soon.
Okay, it's a different, you're going to end up working on a different project in a way, or a different
protocol? It's not perfect. I can give you an overview, but
sure.
But I didn't want, I just joined.
No, actually, this is what we're trying to kind of do, right? This part of I think you missed the sort of intro part where I mentioned the goals, but one of the goals is to start mapping what are the different kind of groups, what are the different systems that are being introduced among, like, that we know of among this smaller group of the zkStudyClub. And this is sort of a starting point for us to discover it. So if you are working on one of these systems, I think it's interesting to hear what it is.
Okay, but so super short intro.
Sure.
My name is Matteo. I work at Google, but this doesn't have anything to do with my work at Google. However, if some of you comes up with a super cool scheme or whatever, given my advantageous position, I could bring it to the attention of relevant teams inside Google, because as you know, Apple and Google are, collaborating on implementing contact tracing. So yeah, okay. So this other scheme, it's based more on asymmetric. And by the way, I'm not a cryptographer. I do mobile development, so I will say a lot of incorrect stuff. But basically, it's about using public key cryptography, so asymmetric keys. So if there are two people in a room, people basically, they just advertise their public key, which is 32 bytes with elliptic curve cryptography. And then if somebody gets infected, so they want to tell other people that they're infected, they take all the public keys that they received and they encrypt a message containing also some randomness that says, hey, I'm infected, and optionally they also include the time of the day and the location, and they send it to the server, and they always pad it with random data so that whenever a person says, hey, I'm infected, this blob of data of these messages, hey, I'm infected, all encrypted with public keys of people, it has always the same size so that the server cannot infer how many persons did this person infect. So the server doesn't know who this person is talking to, and the server also doesn't know how many people this person infected. However, the people that receive this feed of infections, they attempt to decrypt these things, and if they manage to decrypt one of them, it means, oh, I had a close contact, so I could be infected. And also to prevent inflating fake contacts, because you could be stealing someone's public key and advertising it all over the world, you want to also send a signature of the current timestamp with the public key that you broadcast. So this is how it would work. And there's a paper that's coming out.
And this is the project that, is there a name for this yet, or?
Yeah, it's the WeTrace. So we were the winner of a hackathon. It's called, the app was called WeTrace. Let me paste it to the chat. There's already a preliminary paper, but it's like a really disgusting draft, but let me find it. WeTrace. So the app was wetrace.ch. The code is really incomplete, but let me paste the
wetrace.ch. Got it. Yeah.
Yeah, and the white paper is here. This is the draft, so that ignorant people like us without cryptographic knowledge wrote, and the new one will include all these other additional things that I told you about.
Cool. That was another point I did want to touch on, this kind of Google and Apple announcement that they were doing something. I wondered if anyone had any insight into what they're actually doing, and if there is actually any privacy technology included in that, or if it's just they're rolling out updates so that you can push your information. Like that's, like I was kind of trying to go through the articles that I've seen to see if I could find something, but I haven't yet. Does anyone know anything about that?
Even if I had some insights, of course I wouldn't be able to share them, but it's all public, luckily. So Google and Apple, they share the spec and the cryptographic protocol online.
Okay.
So I can paste it in the chat, and it's actually the most simple, worst protocol you've heard out of all of the one that you.
What is it?
Yeah. I mean, it's just this ID broadcasting, and it's susceptible to fake close contact, inflation, if you want to call it. So basically, if I take the ID of a person with my antenna in the main station, and then I have another antenna in another city in Switzerland, I can just rebroadcast this ID, and I can basically kind of like fake close contacts and block a country's economy, because everybody will have to quarantine themselves because they got the notification, oh, you're probably infected. So it's based on that. Let me find
if you can share that, that's awesome. And also if you can share any of the rebuttals or any of the analysis, that would be interesting too.
But on the plus side, away from crypto, what I gather from it is that and I'm not a mobile developer, native app applications accessing Bluetooth in the background is non-trivial, and this update gives us that for free. So while Google and and Apple do what they want. It allows anyone else building contact tracing apps to leverage background Bluetooth. So that's
this is one of the
not really. So I'm an iOS developer, so I looked at the API, and it doesn't really open up background more than it is now. It doesn't really open up Bluetooth more than it is now for app developers. They instead have an API that allows you to start this contact tracing, but the protocol and all of these things, you can't change anything there. You just have to you have methods to get the IDs that you received, and like really basic stuff. But it's not that you can build a new protocol. You're bound to use with to work with the protocol by Apple. I'm finding the iOS classes and crypto scheme that they are proposing and pasting it into the chat now.
Cool. Is there any other projects that have crossed any of your radars that you want to mention here? And if not, I actually have some other questions. Sure.
Yeah, actually, I just remembered that some people at Calibra, we were using the protocol that actually was submitted to zkProof called Proofs of Liability to do some kind of work on proving corona. It's not contact tracing. It's actually when you're claiming a certain number of infected people in a region, you want to prove in zero knowledge certain properties of that claim in some sense. I think that's what they were going to use it for. So it's a bit of a different use of cryptography for coronavirus, but it's still quite interesting.
Henry?
So one event that might be of interest to the people in this group, which I'm going to paste a link to, is there's a very Rush organized seminar organized through MIT called Impact that is going to happen tomorrow online. So if anyone is interested, that might be a thing to consider going to, or sitting in on.
I want to turn that on.
So there's discussion of like different perspectives on contact tracing, and the last panel is going to have a discussion of the different some of the different cryptographic approaches that have been proposed so far.
Nice. That sounds very relevant.
So Henry, I see from the link you sent in the last panel that Ran Canetti is talking, and apparently he's got this private automated contact tracing title to it. Does that mean that he's also working on something, or is he part of the TCN?
There's two schemes called Pacts.
Okay.
I don't know exactly what is going on there, but yes.
Fair enough. Cool. Anna, did you add to the list the one by Evernym? The presentation that I sent, I guess, doesn't exactly cover it, but
I didn't.
I did read that. Yeah, okay, so let me find the link, the exact link, and I'll send it.
Sure, that sounds good.
So about these pacts, I was reading the one from the Coast East, because apparently there's like a East Coast and West Coast pacts. And the East Coast one is quite similar to the one from the European consortium. There are very few differences. The West Coast one, I don't know. And I think that it was just a coincidence of names, but I'm not really sure about it.
Okay, I think we can continue to, I think we can continue to like bring up any projects that we're thinking of. But I did wonder, like, I had just some other questions, and I don't know if you have answers to these questions, but these are just sort of things that I was thinking about. In the systems that we've listed so far, maybe we can focus on the like the contact tracing that Henry's working on and this PEP, PT, are there actually is there any zero knowledge technology in there, or are those something else? And if there's something else, what are they usually?
At least in the TCN protocol that I have been helping with.
Yeah.
The only zero knowledge component comes in the form of a signature, which is very advanced. But essentially, in both this protocol and the AG protocol and some others, you have a system where you're basically, you broadcast random identifiers on Bluetooth, and then at some point later you decide that you want to send a notification. So you create some reports about the identifiers that you've broadcast, and then upload those to a server. Everyone can download them and compare them against what they observed. And one idea that you can use to make this more bandwidth efficient is you can derive lots of ephemeral identifiers from some symmetric secret, and then only upload that sort of seed material. And in the TCN protocol, what we do is we also bind the generation of all of the ephemeral IDs to the verification key of a signature scheme. And when you submit a report, you produce a signature. And the way that you can think about this working is in the case where you just have some seed and you do some symmetric crypto to derive all of the ephemeral identifiers or the temporary contact numbers. When you publish your seed, you are proving knowledge of the of material that was used to generate all of the temporary contact numbers. But doing so in like the most trivial kind of proof of knowledge where you just reveal what the witness is. And so this means that then the clients, for this to be secure, either the client or the server has to implement stateful replay protection, because otherwise someone can include numbers that were previously reported in their own report. And so having this, having a signature and binding the generation of all of the TCNs to the verification key of a signature scheme lets you have an additional sort of zero knowledge proof of knowledge involved, even though it's just in the simplest form of a signature. And that prevents sort of resubmission and lets you basically, it's not necessarily important for all of the clients to verify these signatures, but if the server is verifying the signatures on report submission, then that lets you basically have the server statelessly verify that only the person who actually generated the relevant numbers is the person who is submitting them.
Okay, that was what you were trying to protect for.
Yeah.
It's just that it's correct.
So we wrote up a list of properties for ideal functionality and trust assumptions, which I'll just paste into the chat.
Sure.
And
I'm gonna record everything that we have because there's a lot of good links here, and I'll share that after. So
at the bottom of that section, there's a list of properties saying ideally the protocol should have the following properties. And we split it up into source integrity and broadcast integrity. So source integrity is the property that users can't send reports to users that they did not come in contact with. or send reports on behalf of other users. And having this signature, so if you do the symmetric crypto derivation procedure, as in the AG protocol and others, you get source integrity only until the first report. And adding a signature gives you source integrity always.
Got it.
And that means that you don't have to worry about replays.
Cool. Does anyone know in the PEPPT1, is there, or the DP3T, is there any zero knowledge in that? What systems are they playing with?
So I think DP3T is the actual protocol and the effort that has had like sort of more substantial work put into it.
Okay.
The PEPPT is
the organization.
some kind of, it's unclear. There's some kind of umbrella organization. I'm not sure. Okay. From my vantage point, it feels like the DP3T effort specifically have done a lot of work, and I'm not sure about others.
Okay. And what's in that? Does anyone know what's in it?
What do you mean? How the protocol functions? Or?
Like what kinds of systems are being used in there that we might be familiar with?
I mean, it's these ephemeral IDs. So these, they all, yeah.
Is it similar then to what you're doing, Henry?
I think it's a bit worse than what Henry proposed. So I think Henry's solution probably is better. So yeah, they also have these secret seed that generates all these, where they derive all these ephemeral IDs from, and then they broadcast them, and then at the end they upload the seed that was used to generate these ephemeral IDs to the server, so that people can then, you know, download that and yeah, basically check, like rederive all these ephemeral IDs and check whether they have any stored ephemeral ID that they received. It's kind of basic, no?
Am I confusing this with the one that actually requires a TPM to prevent like a false reporting one, or is it the same thing?
They mentioned TPMs in their paper, I think, as a future sort of additional layer of protection. I'm not sure. Another point that I would make about DP3T is that they did a first iteration of their protocol, and they have also done a second iteration that I think uses Bloom filters in some kind of a way.
Okay.
But
they're actually using Cuckoo filters. Cuckoo,
cool.
What are they called? Maps
Hash.
or yes.
Oh, okay.
But I have not at all. I have been kind of swamped, so I have not yet come up to speed on the latest version that they have. Okay. Sorry.
I saw the earliest version. Is it the one by Sergey Votny and the what's his name? Whatever his name is. Analysis of DP3.
Yeah,
DP3T.
This is the article that I just posted in there.
Okay, all right.
The e-print there.
Yeah, sure. I had a look at that one. Yeah.
But anyways, the reason why I am really thinking this DP3 method, like I think the biggest limitation is this attack that I was talking about before, which is the inflation of contacts. Let's say, as I said before, you put up an antenna, you receive all these tokens, you immediately relay it in another city, or in other parts where you have an antenna, or if you're a group that wants to attack this, everyone has an app that rebroadcasts all of this, and it's basically generating all these close contacts that don't exist, and you could attack a country by making this system ineffective.
Yeah.
So the contact relay attack, or I don't know how we want to call this is the major problem with that solution, in my opinion.
There are some proposals to mitigate that. There was something in the e-print of the IACR by Christoph Pietrzak that where basically The idea is that you include some information about the location and time.
Time would be the interesting thing, I guess.
Yeah.
Yeah, if you have a window, then the replay attacks are very timely bounded. Yeah.
So the idea is basically that you are sending your ephemeral ID, and at the moment where the other person like receives it, then the other person needs to check whether the location and time that are hashed somehow in the information that they correspond to the one that they should. So actually, then you don't need to send your location and times to the server at any point, if I'm correct, because
I'm not sure I understood how that would work, because if you just send a hash.
So basically, you send the information with the time and location, and then you send some hash that includes the time and location, and then the person that receives that will check against its own time and location and see that it's actually correct at the time of receiving the ephemeral ID. So you can actually check that it has the correct information in it. So that then you cannot like replay, you cannot relay it in that sense, because if you are like getting an ephemeral ID and then sending it to somewhere far from you, and then the person that will receive it there will check that actually that's not consistent with the location where this other person is at that moment.
I was about to say, even this attack is known in IFF as well, so you can actually have this attack happen. Historically, the Israelis in this call, so they will explain it. It's a publicly documented attack on IFFs. So you could probably do, windows, as in like very tight window, then you can't actually have a loop, and then you can't come back. So that would be the easiest solution to this.
Yeah, so this attack is still possible, but it needs to be to happen in like very sort of so close by and at the same time. Otherwise, you cannot have this.
Yeah.
But how much data would it add to the advertisement packet?
I don't think it's discussed, because I don't think that the proposal actually, at least if this is the same ePrint that came out quite recently, I skimmed it only briefly, but I don't believe that they actually considered the physical constraints at all.
Yeah.
Because we are pretty physically constrained to 16 bytes. That's the advertisement data that the Bluetooth specification supports. So whenever you're broadcasting something, you're broadcasting, this and that, and then you have these 16 bytes where you can put something inside there. And I still didn't quite understand how that would work. But I also heard about another solution, which is not ours, that would mitigate that attack. But if you wanted to say something else before.
I wanted to make one comment about the earlier paper, the 2020-399. I found it kind of frustrating to read, because it was parts of it read sort of like when someone is doing like a vulnerability analysis and they kind of like throw in the entire kitchen sink of everything that they could think of. And it was kind of hard to parse out which of the problems that were identified were actually problems, like which ones were just sort of complaints. So for instance, one of the problems that was supposedly identified is like, oh, well, someone can impersonate the server and like, show up at someone, like broadcast numbers to them and then send them a report while they impersonate the server, and then like, oh, well, this would be addressed if the server were authenticated. And it feels kind of like, well, the people who are writing up this protocol, like maybe they didn't include explicitly the sentence that like the server uses HTTPS, because that's just kind of like a baseline assumption. And it felt kind of, I was a bit frustrated that I did not feel that the attacks were really all at the same level of practicality and severity.
Antonio just added another link in the chat here that is another kind of attack paper on DP3T.
Yeah, replay attack, yeah.
It's interesting. And that just came out 2 days ago, I think. There's some people in the chat who haven't spoken, and I just want to open up the floor to them if anyone else wants to sort of weigh in about what we're talking about. I mean, for anyone who's newly joined, we've been covering a lot of the different systems that are out there and talking about some of the pros and cons, trying to explore a little bit what's in them. And obviously we can't cover everything. We're just like a small group, so we're just kind of pooling together some of the info we have. I know one of the other topics that Daniel, you wanted to cover was about the barrier to getting some of these things adopted. But yeah, I wanted to kind of open the floor to everybody else here if anyone wants to mention anything, if there's systems that they've heard of that we haven't mentioned yet, or if there's other ideas around those that we have, or if you want to talk about this adoption question. I just want to throw it out there. Okay, so Antonio actually is having a bit of trouble with his mic, but this is the paper, and I think, yeah, I think we kind of, we're all exploring that paper now, and Antonio, so thanks for sharing that. I'm sorry that your mic isn't working. And you're all muted, so if you do want to say something, you have to unmute yourself, just FYI.
I was just taking a look at the paper that Antonio posted.
So I'm particularly interested in how this technology gets implemented, especially in more fractured health ecosystems. Because I'm from Nigeria, and I started looking at it, and it's very interesting. When I think of the lived reality of implementing it, it's like these hospitals they're not going to run a server, or they're just going, like it's very good, but like they're the most fragile economies, and how does contract tracing as it stands today lend itself to the developing world, because our problems are very, very rudimentary, and we find that in most cases lo-fi things work. Because I'm thinking, so Antonio said or someone mentioned that when we do get these upgrades, they will be on like the latest Apple phones. But
Yeah.
most people use feature phones like Chaos OS is stuff that's really growing there. So how do this implementations or does anyone know anything that's working in developing world?
Yeah, I could.
Sorry?
Yeah, I probably would put my hand up. So I was born in Kerala and I went to med school there. So I know what's happening there. They actually got, it's part of the reason I wanted to get on this call. So there's a lot of controversy going on. There's a US company that was hired to analyze the data set. So essentially they got the cell data, every device has an MC, and when you connect, your authentication protocol actually reveals some information. You can collect all that. And that has been actually given to somebody else. And this is a trade-off question, and they decided they will actually do that. I mean, at that moment in time, they thought that is the best possible decision. Maybe, I don't know, I mean, this is like a very hard problem that we have. We have a bunch of solutions which are pretty good, at least in the path of being pretty good. But getting it implemented in places where A, is resource constrained, and B, it's pretty hard for the people in that part of the world to do anything. It's going to be tricky because the people who are involved, if we had a solution today, I have a channel to the decision makers. I was on the phone with them yesterday. So if you have a sort of solution, I am happy to connect to the government, the state government in Kerala. So in the state of Kerala, it's kind of an anomaly of the whole of India. We have like pretty interesting healthcare statistic. And we have a lot more doctors per 1,000 people population, way above the WHO limit, I mean, WHO requirement. And we had the first set of COVID infection imported from Wuhan. And we had very few fatalities. But it's an exception. Even there, privacy is something that we had to trade off. Yeah. So if we have a project, I will happily do the intro.
It almost feels often like as I explore these, and maybe everybody feels this way, where it's like there's some really good potential solutions coming up, but they're not quite at the point where you could start to put them on tiny devices or like non-smartphones. And even on smartphones, they might not, like good up-to-date phones, it might also not work there. And so we're stuck with with systems that are definitely privacy imperfect.
So again, given Anish's point on implementation, Carola, would you say privacy is what trading off in that kind of a situation? Yeah. Because privacy is things like privacy and decentralization, they're higher virtues. But if you go to places like in Lagos, there's social determinants. Like people do not care about quarantine because they eat day to day. So every day they go out is a day they starve. So like maybe it's encroaching or scope creep on this conversation. But it's like when we effort to build holistic technological solutions, the social determinants of the demographic really drive things.
I'm gonna put a little note on that.
If I were to put this in context, the whole of India, when they had lockdown, there were like millions of people on the street. So there is no construct of social distancing even happening. And the other thing we should recognize is just starvation kills 100%. COVID virus has a fatality in a percentage, right? Even if firstly, you have a probability of getting infected, and the secondly, there's a fatality, which could be from 0.7 or even less than 0.3 to whatever, single digit. So this is a challenge. Like a lot of the things are trade-offs. So I don't know. An open question for everybody.
I think that in a way is that's definitely a topic that we were sort of talking around in the study club, of like wanting to talk about. It's such a big one, and it's like it's very subjective. I think there's also a lot of emotions right now about that, like some of those topics, because it's like it's sort of the utilitarian good versus the individual good, and it gets really complicated and emotional. You can feel that with some people, and rightly so. Like it makes sense that it is. But Matteo, you want to say something?
Yeah, I mean, am I right to assume that, I mean, after Snowden and so on, I mean, I guess it's fair to say that, I guess, phone companies, Apple, Google, ad networks, secret services, they basically have all the information already, right? They're just not using it, or at least they say they're not.
They don't want to acknowledge it, right? It's like once they use it, that's acknowledged, right?
I guess so if we don't care about, I mean, I care a lot about privacy, but if we say we don't care about privacy, then can we establish that like the trivial solution would be to just make use of all this data that's actually already there? You just add a button, okay, I have COVID.
Mario, the way I think about it is like it's countries acknowledging practices. So I wrote a paper in 2011 describing some of the challenges. And the challenge was like, nobody wants to acknowledge this. Nobody in any of the various groups, okay, would, even if you meet them and you talk to them and they know you really well, they would never acknowledge existence of any of these things. And I'm pretty sure you all have similar experiences. I've at least met the UK equivalent because my PhD mate works there, and I've met a few senior people. They would never acknowledge any of these things. Everybody knows that's the truth, right? But they don't want to acknowledge this. They don't want to release the data set. So, I mean, they don't even need to get to that level. The cell level info is good enough for us. If they could get the IMSI and just track the whole thing out, you don't need to go into a lot of detail. But, even that, they don't want to be revealing. I don't know.
Daniel, I was wondering, since that was one of the points that you had sort of brought up, this barrier to adoption, and since what you guys at Kedit, what you work on is getting enterprise to adopt some of this stuff, I was wondering if you have any thoughts on it. I don't know if you're still there. I hope you are. You're muted right now.
Yeah, I'm here.
Oh, great.
Yeah, it's a great point. So, I mean, I think it's a bit different in the sense that this is really adoption not in the context of enterprise. It's really about consumers adopting this, right? So it's a bit different. But I think I have a few kind of concerns here. I guess the first one is really to make sure that what is being adopted is actually secure, right? I mean, this is, I guess, a typical concern in cryptography. Like I just saw that the European Union published, the European Data Protection Board, right? What the commission that took out the GDPR, took out a letter saying that they would support something more like DP3T, right? And we were just discussing that it's maybe not the right way to go as a protocol for privacy enhancing contact tracing. So this is one of the first concerns or challenges that I see. Another one is actually in the lines of what I asked earlier, like if we see that there are so many different protocols, how do we make sure that either that they are compatible, that they're interoperable, or that we can actually make them, like, unify them into one, right? I mean, Henry's working amazingly on this with TCN to make sure that a few different projects came together and built one unified protocol, but we're seeing that there is still other different protocols out there that are getting traction. And then, of course, there is the final question of, I think Anish pointed to this in the beginning, of whether we're doing self-reporting or we're doing actual attested points, right? And basically, it means that in the two different settings, we need two different kind of protocols for that. That are like, basically, how do you get people to react from the different settings? So that's I guess two different concerns.
Cool.
And there's to head out, but it was great to talk with everyone.
Yeah, I was actually about to wrap up as well. I want to say thanks to everybody for joining this, and I think, like, I don't think this is the conclusion. I think this is the entry point for some of us. For some of you, I know you've already been working on it, but thanks for everybody for coming together. Yeah, and we'll continue.
Thanks for organizing.
Thank you. Thank you, Anna.
Thank you. Bye-bye.